Hello everyone, in this video we will talk about the wireless LAN or 802.11 standard by IEEE. Okay, so let's start with the evolution of IEEE 802.11 wireless LAN standards. Okay, so until now there has been six Wi-Fi versions. There are various standards in 802.11s, but it's beyond six actually. But then the ones that are publicly, used for the commercial for the users are these six versions. Okay, from the Wi-Fi one is 802.11.b. Okay, and Wi-Fi two is A.A. Wi-Fi. They are in the same years. They're coming in the same years. And then so the next version was coming 2003, Wi-Fi G, Wi-Fi 3 or 802.11.g. Uh, and then the next version was dot 11n, and then AC 2013, and then finally AX or Wi-Fi 6. Okay, so so basically the later the versions are they can they have more features and the higher data rates and okay, probably higher coverage, also larger coverage. Okay, so the first version was only 11 Mbps, and then okay, so the A and G they have 54 Mbps, the same. Basically, they have the same modulation and coding techniques, but they are using different frequency range. Okay, this 11A is 5 gigahertz, but then and 11G, but it was using 2.4 gigahertz. Okay, so they also have the same bandwidth. Okay, 20 megahertz. This, by the way, 20 megahertz is the bandwidth of one channel. Okay, in the 11N, they can achieve 600 Mbps. This is the maximum data rates. Okay, please note that this is the maximum data rate, achievable data rate, which is theoretically achievable, and it's also in idle case. They are using two frequency bands, 2.2.4 and 5 gigahertz. So they are using 40 megahertz bandwidth. So basically, they are using two channels, perhaps one in 2.4 at 2.4 and one is in 5 gigahertz. And starting from this 11n, they have MIMO. Okay, MIMO is multiple antennas. So basically, the maximum is 4 times 4. So basically, 4 antennas in the receiver and 4 antennas in the transmitters. Okay, so so basically, this data rates can be achieved by if they are using this maximum configuration, 4 times 4. Okay, and then in Wi-Fi 5, I think they have two release. Okay, so the first release and the second release, where the second release have higher data rates because basically they have more bandwidth. Okay, larger bandwidth, doubles than the previous release. So 80 megahertz for the first one, and then the second one has 160. So basically, here they are using four channels aggregated in the 5 gigahertz spectrum, while in this one it uses 8 channels aggregated together. So definitely they can achieve higher data rates. Okay, up to 6.93 gigabit per second, and they also support 8 times 8 multi-user MIMO. So the difference with this is the previous one. The MIMO is just for one user to the base station communications. But with multi-user MIMO, we can think about like the base station can steer its beam, the signal to different users. Okay, so like they can have different queues for different users. Okay, so this is for this multi-user or single user MIMO. But then it was only for downlink. Okay, but in the Wi-Fi 6 AX, with the AX, it can achieve even higher data rates by using the same bandwidth with the previous Wi-Fi version. But it has it uses two frequency bands, 2.4 and 5 gigahertz. So it supports 8 times 8 multi-user MIMO, but bi-directional. So it's not just downlink but also uplink. So basically, in this scenario, the MIMO can also works for the uplink. So let's say downlink can also works for example, like if we are just downloading materials or streaming videos. But this is also useful if we are like the producer of the video, okay, live streaming, and we have to transfer the video to YouTube or other any other video providers. But then, okay, for the multiple access protocols, all the Wi-Fi versions up to 1 to 5, they are all using CSMA that we will explain about this later. Only in Wi-Fi 6 they are using it is using FDMA. This is a bit different, different approach from the CSMA CA. So, but then we're not going to talk about the FDMA. We're just going to talk about CSMA CA probably in the next video. Okay, now let's talk about the wireless LAN architectures. It consists of base station and wireless host. But what base station in this Wi-Fi is also known as the access point. Okay, and then there is also another term called the basic service set, or it is also called a cell. Okay, this cell or basic service set consists of the wireless host and the access point. Okay, or the base station, but in the ad hoc mode, there's only host. Okay, there's no access points. Now we'll see the wireless channels of the 802.11 in the 2.2.4 gigahertz. Okay, so basically there are 14 channels, or okay, 13 channels for, let's say, for America, for US, and for Indonesia. But then maybe in Europe there can be up to 14 channels. So as we can see that here, channel number 1 up to 13, among those channels, only channel 1, 6, and 11 that are not how to say, they are not interfering with each other, or overlapping with each others. Okay, so that's why normally we are using, if we are setting up our Wi-Fi access point, so we choose the channel number 1, 6, or 11. This is the default channel for the Wi-Fi access points. Okay, and then each channel the bandwidth is 22 megahertz or 20 megahertz. Okay, that's why when we have this bandwidth 40 megahertz, then they are using two channels aggregates. Okay, you can see from the Wi-Fi analyzers actually. Okay, so now the channels and associations, as we can see before, spectrum divided into channels at different frequencies, and as admin we have to choose the frequency for our access points. So we have to avoid interference. So if it is possible, then we have to scan the neighboring Wi-Fi access points, what channels they are using. So and try to use different channels than our neighbors. Okay. So now, from the perspective of the host, if the host wants to join to the access points, first it scans the channel. So this is the typical flow. Scans the channels. And if we are looking at our device, well, it's the Wi-Fi device. We can see list of Wi-Fi access points which are available. So basically, it's coming from the beacon frames, that is broadcasted by the access points, and then it's captured or listened by our device. Okay, so it contains the SSID of the access points and the MAC address, and then we select which access point that we want to associate with, and then we have to perform authentications, and we can see if authentication is being performed. Then it is written authenticating. Okay, if it is required, then finally, after the authentication is successful, then there is DHCP to obtain the IP address. Okay. Now we also have this passive and active scanning. So this passive scanning is a typical scenario when we just listen to the incoming beacon frames from the surrounding access points. Okay, and then once we have a list of all the access points in our surrounding, our environments, then we can send association request, let's say to access point 2, and then the response will be sent from access point to the host. Okay. Now for the active scanning, the host basically send a prop request to all the the access points in the surrounding. Okay, that is in its coverage. So for example, we can use in the Linux terminal, we can use the sudo iwlist scan. Okay, so this is also like a type of active scanning. And then we receive the props response from all the access points in our neighboring or or in our environments or surroundings. Then we choose one of the access point that we want to associate with, and we send this association request from H1 to selected access point. Then we get the response frame from the selected access point to the H1. So I think that's it for the introduction, the Wi-Fi introduction. We'll continue in next video with the CSMA or the multiple access protocol in the Wi-Fi 8.0 to 11 from Wi-Fi 1 up to Wi-Fi 5. All right, then see you again in the next video.